Welcome to Brain Vision.
So here on this problem we are given this rocket that has a reach up to a certain distance in the atmosphere, and the mass of the rocket at this instant is 2.80 megagram, and the fuel is burned at the rate, this is 120 kg per second. Now this angle theta is given to be as 30 degree. Now the exhaust velocity we are given to be as 640 meter per second at the given instant, and the acceleration due to gravity we have to consider at the given altitude is 9.34 meter per second squared. And we have to calculate the n component and the t component of the acceleration of the rocket. That means we have to basically we have to calculate the acceleration of the rocket in this direction and in this direction. So these two things we have to calculate, and to solve this problem we can use Newton's second law of motion, which says that sigma ft is equals to mass times acceleration in t direction. Now we're going to see the forces in the t direction. So one force is this thrust force T, so T minus, now if this angle is theta, so this angle would also be theta, so this force would be mg cosine theta. So it will be equals to m times at, so m times at as it is. Now let me first calculate the thrust force T. So thrust force T would be equals to m dot times u. So m dot we have 120, that is the flow rate, times u is 640. So we're going to solve this and we'll get the value of T to be 76.8 times 10 to the power 3 Newton. Now we can put the values here. So thrust force we have 76.8 times 10 to the power 3 minus mass is 2.80. We'll be taking the values in kg, so it would be times 10 to the power 3 kg, times g is 9.34 times cosine theta. So theta we have 30 degree, and it will be equals to mass 2.80 times 10 to the power 3 times the acceleration 80, and from here the acceleration 80 comes out to be as nearly 19.34 meter per second squared. So this is the acceleration of the rocket in the direction t, in this direction. Now we can calculate, in the next part we have to calculate the acceleration of the rocket in this direction, this one. So for that again we can use the same law, the Newton's second law of motion. So sigma Fn, this time in the n direction, and it would be equals to m times an. Now in n direction we have only one force, that is mg sine theta. So it would be equals to mg sine theta, and it will be equals to the mass as it is, an as it is. Now here this m and m will cancel out, and we'll get the expression for acceleration an to be g sine theta. Now we can put the values. So g we have 9.34 times sine theta, so theta we have 30 degree. So we can solve it and we'll get the acceleration to be nearly 4.67 meter per second squared. So this is the acceleration of the rocket in the n direction. So this is the final answer. I hope you have understood the problem. Thank you.